Hey guys, Mr. Race here to help you out in Algebra 2 with the 6.7 notes. We're going to spend 2 days on this section, but we're going to just kind of do everything in this one video. So feel free to pause or skip forward ahead of this video if you're working on day 2 or day 1. All right, so what we're going to look at is the logarithmic functions. So these are always log-based functions. Now, this generic form that they give you here can probably be better explained by a different example. So let's say like we had a normal log. So log base 3 of 10 equals x. Remember, what we can always do is to loop and swoop to set up the expression. All right, and we could go ahead and let me change the color here. We can take this, swoop it around to get our exponent to that. So we can change this into the equation 3 to the x power equals 10. And we can go through and solve those. Now, a couple things about logs to note here is that if a log is base 10, that's known as the common log, and you will just see that as the regular log. You won't actually see anything here. So if you see log 5, that's the same thing as log base 10 of 5. The other thing here is if we have natural log or a log base e is a special number, like how pi is a special number. That is known as the natural log, or the ln. So ln of 6 is the same thing as log base e. It's like 2.7 of 6. So those things will pop up here and there, and we'll just make sure we understand those. All right, now when it comes to solving logs, typically what we're going to do is to use the loop and swoop method, or if we can't do it that way, we will use a graphing calculator. So a couple things we can do here just to double check like why these answers work out. And so these are just common log rules here, like log base 9 of x equals 0, and the answer is x equals 1. Now the reason why is because if we loop and swoop, we'd get 9 to the 0 power equals x, and anything to the 0 power is 1. So x equals 1. And so that doesn't matter. Like if we had a different problem over here, like we had log base 6 to the x power equals 0. Any log base whatever equals 0, that x there is always going to equal 1, because when we loop and swoop, anything to the 0 power is 1. All right, next, why is log base x of x equal to 0? Why is x equal to 1? All right, so we would have to loop and swoop this to prove this around. So this would be x to the 0 power equals x. Well, anything to the 0 power is 1. And so once again, just like this problem here, we would have 1. And then why is ln of x equal to 0? Why is that equal to 1? So kind of the same thing here. This would be log base e. And if we loop and swoop, we'd get e to the 0 power equals x, and we'd get 1 again. So whenever we have a log or a natural log equal to 0, we go ahead and the x would equal 1. So a couple of things to note here is we can actually have a couple of rules that expand off of that. Well, since log base x of x equal to 0, x would have to equal 1. We have some other ones here. Like log base a of a would have to equal 1, because when we loop and swoop this here, a to the first power would have to equal a. And another thing here is that means log base e of e would equal 1 as well. So e to the first power equal e. Now the reason why this is important is because log base e is the same thing as ln. So ln of e equals 1. So what that means is that the ln and the e cancel each other out. Now on the other side here, we got some other rules to look at, in which we've done. Anything to the 0 power is equal to 1. So the same thing here, ln of 1 would have to equal 0. All right, so those are going to be little tricks that we can help us out. Now we technically don't need to memorize those, since we can use a calculator to verify. But the biggest thing here, we'll make a note, is that ln and e cancel. Or they, we say cancel, but they actually equal 1. So if we're ever going to be solving, if we want to get rid of an ln, we'd have to take to the e side, or vice versa. Some other properties about natural logs here is that natural logs can expand and they can contract. So when we're looking at multiplication here, like if I have ln of a times b, we can actually break that up into natural log of a plus the natural log of b. And so you can see here the ln of 5x is the same thing as the natural log of 5 plus the natural log of x. Now that works for all logarithms. So if I had the log of x, y, we can change that to the natural log of x plus the natural log of y. Now, division works the same way, very similar, except for it be subtraction. So the natural log of a divided by b turns the natural log to a minus the natural log of b. So we can subtract those in the middle. And it would work the same thing with log. So if I had log base 6 of x over 5, that turns out to the log base 6 of x minus log base 6 of 5. And then the last rule with logs here is that if we have a power, it can actually be multiplied down in front. So log base 5 to the x power, this x can go down in front, and it's x times log base 5. So we're going to use these things to just expand and contract. In fact, let's jump to into a couple of these examples here to make sure we understand how to do these. So we got all these rules here that we can apply. We're going to jump into this, and we might go through a couple examples in our homework. So first note here, how do we solve the natural log of x is equal to 4? Well, a couple things to note here. Maybe we could loop and swoop this if we want, and we could change this to log base e of x is equal to 4, and we could loop and swoop this to solve. This is kind of the long technical way, but we're going to show you another thing to do. So we can say this would be e to the 4th power is equal to x, and we can go ahead and just type that into a calculator here. Switch over to a calculator. Ooh, it's pretty large, but it'll work. And the e button here, if we got to press second ln to get the e, 4th power, and there's our answer, 54.598 2 if we round. Now here's the other note that I want you guys to note here, or the other thing to really take away from this, is that the ln and e cancel out. So to get rid of e, or get rid of ln, what you got to do is e both sides. Kind of ran out of room there. So just to do this problem over again, if we want to get rid of this ln, I technically take e to the ln of x power is equal to e to the 4. Now this e and the ln we kind of talked about up front, they cancel each other out, and we're just left with x is equal to e to the 4th power, which is what we have here. So we can get the same thing. Now the reason why this step is important is because we can go here. Now this problem we can kind of loop and swoop, and we'd get, okay, log base e of 10 is equal to x, and that would be the ln of 10, log base e of ln. But if you just notice here, we can make another note to get rid of e. We'd ln both sides. And so if we would have just said, if I want to get rid of this e, I have to ln the other side and just do ln of 10. We just type that into the calculator. So grabbing the calculator again, natural log button's right here, natural log 10. There's your answer. And we can always just kind of double check these things out. If we went to plug it back into the original question, e to the 2.302585093 power is equal to 10. So first thing, e's and ln's cancel each other out. All right, now we're going to do this one together here. So let's do this the quick way instead of doing the loop and swoop way. So if I want to get rid of this ln here, I'd have to take e to the other side. So x equals e to the -2 power. So all you got to do then is to take out a calculator, second ln, -2. So there is, we went over the loop and swoop method, which is kind of a long, complicated way. It's the mathematically correct way of doing it, but now we kind of know a shortcut here. If we see an ln, we just take e to the other side. So we go to the 4th decimal here, we get 0.1353. All right, now if I want to get rid of the e, we got to ln the other side. So we get x plus 1 is equal to the ln of 1 right, and we can go ahead, take out a graphing calculator. All right, what is the ln of 1? It's 0. Okay, that's nice. Actually, that was a rule from above, right? And so we get x plus 1 is equal to 0. So x would have to equal -1. Okay, so not too bad. ln's and e's cancel each other out. All right, so how can that help us with this problem here? Well, if we can isolate the ln, we can eliminate it. So just like any problems that we've done before, when we isolate it, it gets eliminated. So to get rid of this ln, we'd have to e the other side. So x minus 1 equals e to the third power. Okay, and so let's go through and figure out what decimal that is. All right, e to the third power is 20.8 or 0.855. Okay, and so x minus 1 equals 20.0853. We can add 1 over to that, so x would equal 21.0853. Piece of cake. Now, where it gets a little complicated is when we have these multiple ln's. If we want to eliminate the ln, we have to e both sides, but that just gets rid of the ln here. When we have multiples here, it's almost like when we have multiple radicals, but there's a trick that we can do. When we have multiple ln's, we can combine those together. So if we remember, like if we had ln of something times something, we could split up to addition. We're going to go backwards here. We're going to compress this. So we can actually compress this to the ln of 2x plus 1 times 2x minus 1 equals 0. All right, so let's e both sides here to get rid of the ln. And so those would cancel out, and we'd get a 2x plus 1 times 2x minus 1 is equal to e to the 0 power. All right, so we'd have our 2x plus 1 times our 2x minus 1. E to the 0 power is 1. All right, so now we just need to go through and solve this quadratic. So this is a kind of tougher problem, but we can handle it here. 2x times 2x is 4x squared. 2x times minus 1 is a negative 2x. 1 times 2x is a positive 2x. And 1 times negative 1 is a negative 1. Oh, and that equals a positive 1 on the other side. Okay, so this is quadratic. It means we got to minus this over here to make this equal to 0. We get a 4x squared is equal to, actually, I put an equal sign here. Shouldn't be an equal sign. Let's see, we minus that over, minus 2 equals 0. Okay, we could try to factor this here, but it's not going to work out nice, so we'll take our time with this. We're going to add the 2 over to the other side. 4x squared is equal to 2. Then we divide by 4, so we get 1/2. And then we take the square root. So x equals plus or minus the square root of 1/2. And that ends up being plus or minus the square root of 1 is 1, the square root of 2 is 2. If we want to get real fancy, we can say this is plus or minus radical 2 over 2. Now that one was a tough problem, way tougher than any of them that you guys will see for a while, but let's go over some easier ones, just kind of build back some confidence here. So if we want to isolate this e or get rid of it to get this exponent, we got to isolate it. So let's get rid of this 5 here. We're going to divide by 5. So we get e to the x minus 3 is equal to 4 divided by 5. All right, to get rid of the e, we got to ln the other side. So x minus 3 is equal to the ln of 4 divided by 5. Now we could split this up, but really we're just going to type it into the calculator. So take out your calculator, and we can just type in ln of 4 divided by 5. It will do all the math for us. We get negative 0.2231. So we get x equals, or x minus 3 equals negative 0.2231. And all we got to do is add 3 over to the other side. And this is why the calculator is super nice in this chapter. All we got to do is just do plus 3, and there's our answer, 2.7769. All right. All right, one more problem here, and then we're going to look over the homework problems and kind of give you some hints on them. All right, so if we want to get rid of this e by itself, we first got to divide by 4. So e to the 2x power is equal to, all right, 24 divided by 4 is 6. Not too bad. All right, now let's get rid of this e. So we'll leave the 2x, and to get rid of the e, we have to ln the other side. Let's figure out what that ln of 6 is on the calculator. So just press ln 6, 1.7918. Okay, so we get 2x equals 1.7928. All we got to do is divide that by 2 to get the x by itself. Now, the big thing here, guys, make sure you know on your test or your quiz or anything, you're showing your work. So that way, if you make a small mistake, I can give you partial credit. If you're just putting the answer down, I don't know where you got the answer from. And so there we get, oh, I already forgot what that answer was. 0.8959, 89.559. And there we go. Okay, so you can see logs work by expansion and contraction, and the biggest thing here with common logs or natural logs is that e's cancel them out. So let's go through and look at some of the homework problems that you guys have to do. All right, so on this page here for worksheet A, what you guys have to do is to solve each one of these problems. And most of them are pretty simple here, and you have answers down here that correspond. So like in number 1 here, we got solve for t here. If we want to get rid of this e, we just ln the other side. So we have t already by itself. And so for number 1, we just got to figure out, okay, what's the ln of 100? It's 4.6052. So is that somewhere on here, 4.6052? Oh, actually, you know what? It's probably close enough here. Wait, 4.60? Yeah, so there we go, 4.60, 4.6. All right, and then like for number 4 here, if we have the ln of t, to get rid of the ln, but keep the t, we e the other side. So we're going to take e to the 2nd power for number 4. E to the 2nd power is 7.3891. 7.38, or basically 7.4. Actually, it's not even there. It's just right here as the answer, e squared. That would be the exact answer. So some of these aren't too bad. You know, this one here, we have to go through and isolate them and to cancel them out. And then some of them we have to combine. So I'd probably use some process of elimination to help you out. Now check some of them out as like previous examples up here. Like, so the problem that's like this problem here, like E, would be very similar to 13 or 16 on your work. Once you get down, you can always just plug them in to check and see. So if you get down to like 2 or 3 problems left, you're not sure which one they are, but you have 3 questions left or 3 answers left, just plug them in to check. All right, and then for worksheet B here, what you guys are going to do is to solve these. So we didn't spend too much time on it, so I'm going to go through this now, is this expanding and contracting of these logarithms. So if we wanted to go through, maybe we'll kind of work backwards here. To expand and contract these logarithms, we have to break down what each of them is. So this problem here, this first one here, we have all of this to the 4th power. Well, the 4th power, we know by rule, go in front. So really this is 4 times the natural log of 8 to the 5th power over 7. Okay, well, if we have division in here, we can subtract that or move that around with subtraction. So this would be 4 times the natural log of 8 to the 5th power minus the natural log of 7. And then we can actually break this down even more. Right here, we could put that 5th power. So the final answer for number 1 would be 5 times the natural log of 8 minus the natural log of 7. All right, let me help you guys out with number 2 here, because this one's a little tricky. All right, so we could break this up into a bunch of addition. We could change this to the natural log, since it's c times the square root, be natural log of c plus the natural log of the square root of a plus b, or a times b. I'm already kind of thinking ahead. ab. All right, well, if we remember, the square root of AB is the same thing as AB to the 1/2 power. The square root is the 1/2 power. So we can take that 1/2 power and move it in front. So we'd have the natural log of C plus 1/2 the natural log of a times b. And then we can actually break this up. So the answer for number 2 would be the natural log of c plus 1/2 times the natural log of a plus the natural log of b. So these expansions aren't really too bad. If you look at here, anything multiplying, you're going to be splitting into adding. So this would be splitting into adding, splitting into adding, splitting into adding, but then we'd have to move the 6 in front of the z. So like for number 4, we'd have the natural log of x plus the natural log of y, and then plus, not the natural log of z, but 6 times the natural log of z. Now, it might actually be easier for you guys to do the next one when we have numbers here. So how do these numbers here, if we were going to compress them into a single natural log? So if we're going to compress them, any number outside is going to bump up to become the exponents. All right, so this would be natural log of 5 to the 25th power minus natural log of 11 to the 5th power. Then look at this and go, okay, the subtraction would go into division. So the answer here would be natural log of 5 to the 25th power over 11 to the 5th power. So we're just contracting. Just to help you guys out with like number 2, since we have the division here, remember that's the same thing as 1/2 times. Oop, 1/2. All right, so you would go through and bump these up the power, and then go through and multiply them all together. Next group of problems are actually real easy. Just use a calculator here. So we're just approximating, so you just type it in, natural log of 39. Probably could have even taken these out here, but we're just gonna use them. Okay, so let's talk about how do we solve these problems. And these ones are actually fairly easy. If they have a natural log on both sides, they cancel each other out. So you got 7 minus p is equal to negative 5p minus 1. So move this over here. So we'd have, and then move this 7 over there. So if we add 5 over here, we'd have 4p. If we subtract 7 equals negative 8, so p would equal negative 2. So a log on both sides, they cancel each other out. The log on same sides, they don't cancel each other out. You have to combine them. So this problem here, we look, okay, this would be division. So this is the natural log of 8 divided by an x plus 4 equals 1. Now, if we want to get rid of the natural log, we got to e the other side. So 8 divided by x plus 1 is equal e to the first power. To get rid of the natural log, we e the other side. So calculator time here. All right, what's e to the first power? I think it's like 2 point something. 2.7183. All right. So we get 8 divided by x plus 1 is equal to 2.7183. All right, we're going to cross multiply divide here. So I'm going to write over here because I'm running out of room, but we cross multiply here. So I get 2.7183 x plus 2.7183, because I distribute that to the x plus 1, times it by x, times it by 1, is equal to, across the other way, 8 times 1 is 8. So we're going to take 8, we'll subtract the 2.7183, and then we'll divide that answer by 2.7183. So in a calculator here, we double check it. 8, making sure, yeah, we subtract minus the 2.7183. We get an answer, and then we divide it by 2.7183. So the answer should be about 1.943. All right, let's try another one of those here just to make sure. Let's look for a scary one here. Let's do 21. All righty, so here we go. Grab a drawing tablet. There we go. So we got to compress this to get rid of. All right, so if we compress this here, we get natural log of 2x squared minus 2 divided by 9 is equal to, now this natural log was on the other side, equals 80. Now, when we have a log on both sides, we just cancel them out. Technically, we take e to the both sides, but those just go away. So we get 2x squared minus 2 over 9 is equal to 80. All right, let's cross multiply to solve this. Okay, so we multiply the 2x squared minus 2 times 1. We get 2x squared minus 2 is equal to, we can times 9 by 80, we get 720. All right, we'll add 2 over to the other side. 2x squared is equal to 722. We can divide by 2. X squared would equal 722 divided by 2 is 361. And then we can take the square root of that. Now, probably isn't going to come out nice. Actually, it does. It comes out to be exactly 19. Took the square root. Not too bad. So when you have logs on both sides, they cancel each other out. Sometimes you have to compress 2 logs to get 1 log on both sides to cancel each other out. But if you don't have a log on the other side, that's when you have to take e to it and get some decimal numbers. All right, and then the last group here is how do we get rid of the e? To get rid of an e, we have to isolate it first. So in this problem here, we're going to divide by 8. We get e to the negative p power is equal to negative 49 divided by negative 8. Then what we need to do to get rid of the e, to make this a negative p, you're going to take the natural log of the answer, so whatever 49 divided by 8 is. Then all we need to do here is we get our answer, whatever that answer is, you'll divide it by negative 1. So, all right, if we go through and type in the calculator here, what's the natural log of 49 divided by 8? Get 1 point, and we divide that by negative 1. All we do is just change the symbol, negative 1.8124. All right, so the key is to isolate it. So if you look at like problem 25, we got all this going on here. First thing you got to do is subtract this 8, right, 7, subtract 8. We get e to the negative 4x power is equal to 35 minus 8 is, what's that, 27? All right, now let's take e. So natural log, oop, forgot to put the e there. If we take the natural log, it goes away. So we get negative 4x. Get rid of the e, we have to take the natural log of 27. And then if you want to get real fancy, you can actually say x is equal to the natural log of 27 divided by 4. And then just plug that into the calculator. Just take your time, do the natural log part first, and then divide by 4, and there's your answer, 0.824. Okay, you guys should be good with this here for both days. If you guys have any questions, make sure you guys ask, and then always reach out. If not, I will see you guys next time for the review because we just finished up chapter 6. Have a good one.